Next, we will consider one of the standard continuous random variables called uniform and discuss how to work with it. Let's start with a definition. A uniform probability density curve with parameters A and B is a horizontal line going from A to B. The line is 1 over B minus A units above the x-axis and only covers the values from A to B. A random variable with a uniform probability density curve is called a uniform random variable with parameters A and B. We adopt the following notation to denote a uniform random variable with parameters A and B. For example, if x is a uniform random variable with parameters -1 and 3, then its probability density curve will look like a horizontal line spanning from -1 to 3, 1/4 of a unit above the x-axis. Easy to see that the graph satisfies the criteria for a probability density curve as it is above the x-axis and its area is the area of a rectangle with the base 4 and the height 1/4, which can be found using the formula for the area of a rectangle n is equal to 1. Let's find the probability of x being equal to 2. As we previously discussed, the probability of a continuous random variable being equal to a single value is equal to 0. To find the probability that x is less than 2, we will look for the area under the curve between -1 and 2. This region is a rectangle with the base 3 and the height 1/4. The area can be found using the formula for the area of a rectangle and is equal to 0.75 or 75%. To find the probability that x is less than 0, we will look for the area under the curve between -1 and 0. This region is a rectangle with the base 1 and the height 1/4. The area can be found using the formula for the area of a rectangle and is equal to 0.25 or 25%. To find the probability that x is between 0 and 2, we will look for the area under the curve between 0 and 2. This region is a rectangle with the base 2 and the height 1/4. The area can be found using the formula for the area of a rectangle and is equal to 0.5 or 50%. Alternatively, we could have used the subdivision rule to compute the same probability as the probability of x being less than 2 minus the probability of x being less than 0, both of which we already computed previously. So the answer is again 50%. To find the probability that x is greater than 2, we will look for the area under the curve between 2 and 3. This region is a rectangle with the base 1 and the height 1/4. The area can be found using the formula for the area of a rectangle and is equal to 0.25 or 25%. Alternatively, we could have used the complementary rule to compute the same probability as 1 minus the probability of x being less than 1, which we already computed previously. So the answer is again 25%. In general, for any uniform random variable x with parameters a and b and any values c and d, we can discover the following formulas for computing the probabilities. For example, for the uniform random variable x with parameters -1 and 3 that we considered earlier, we can use these formulas to find the probabilities that we already found previously geometrically. In addition to the formulas for computing the probabilities, we also have the formulas for finding the mean and standard deviation of a uniform random variable. For example, for the uniform random variable with parameters -1 and 3, the mean is 2 and the standard deviation is 1.15, according to the formulas. Next, we will go over an application of a uniform random variable. Given that a city metro train runs every 15 minutes, let x be the waiting time of a randomly selected passenger. Let's find the following probabilities and compute the expected value and the standard deviation of x. Waiting time is frequently estimated by a uniform random variable, in this case with parameters 0 and 15. Using the formulas, we can compute all the quantities. The probability that the waiting time is less than 8 minutes is 53%. The probability that the waiting time is more than 3 minutes is 80%. The probability that the waiting time is between 3 and 7 minutes is 27%. The expected wait time is 7.5 minutes, and the standard deviation is 4.33 minutes. We discussed one of the standard continuous random variables called uniform, how to find the probabilities and the mean with the standard deviation.